Hello students. So today I am doing class for class 12 science. The topic is the same topic that we were doing in the last online class. That is, we were doing inverse of a given matrix. So we are doing the application of inverse of a given matrix, that is how to solve a given system of equation with the help of matrix inversion method. So in the last online class also we were doing the same exercise, that is exercise 3. Page number 214. The section is each question carries 5 marks. Okay. Now let's do question number 14. So in this case, what is given? A square order matrix is given. That is, a matrix is given. So its order is 3 cross 3 order matrix. This is the third order matrix. That is, in the first row 2, 8, 5. Second row 1, 1, 1. What is the third row? 1, 2, minus 1. You have to find out A inverse, right? And hence you have to solve the given system of linear equations. That is, you have to solve 2x plus y plus z is equal to minus 5, 8x plus y plus 2z is equal to minus 24, and the third equation is 5x plus y minus z plus 12 is equal to 0. Now first of all you have to find out A inverse. You have to find out the inverse of the matrix A. Then hence you have to solve the given system of equations. So first of all, let us find out the inverse of the matrix A, right? So here the matrix A is given. You have to find out date A, you know that, isn't it? So date A is equal to, you convert into determinant form. First row is 2, 8, 5. What is the second row? 1, 1, 1. What is the third row? 1, 2, minus 1. Alright. Now let us expand it. Or date A is equal to, how will you expand it? You can expand it from any row or any column. So let us expand it from the first row. Right? That is 2, 8, 5. So let us expand it with respect to the first row. Plus, minus, plus. The rule is plus, minus, plus. So plus 2. Now you have to delete the row and the column through the element 2. So what remains? 1, 1, 2, minus 1. That means you have to cross multiply. 1 into minus 1 is minus 1. Then it is minus 2. Right? Then comes what? Minus 8. Now if 8 is considered, you have to delete the row and the column through the element 8. That means first row and second column are deleted. What remains? 1, 1, 1, minus 1. So cross multiply. 1 into minus 1 is minus 1. Then 1 ones are 1. That is minus 1. Right? Then comes plus 5. Plus 5. Now delete the row and the column through the element 5. That is first row and third column are deleted. What remains? 1, 1, 1, 2. That is 2 ones are 2. Then always minus sign is there. So 1 ones are 1. So we have expanded it. Right? So which is equal to, this is 2 into, what is minus 1 minus 2? That is your minus 3, right? Then minus 8 into, what is minus 1 minus 1? Same sign, you have to add them. Plus 5 into 2 minus 1 is 1. Which is equal, this is minus 6. This is plus 16. Then plus 5. Which is equal to minus 6 plus, this is 21. Which is equal to 15, right? So which is not equal to 0. So which is not equal to 0. That means A inverse exists. Right? So you have to write here A inverse exists. Therefore A inverse exists. So if data is equal to 0, if we could have got data is equal to 0, then A inverse does not exist in that case. So in order to get A inverse exist, then data should not be equal to 0. Now here A inverse exists. Okay. So you have to get A inverse now. So how can you get A inverse? That is, you have to find out the cofactor of each element of the matrix A. Right. So you know how to get the cofactor, right? A11. What is A11 actually? Cofactor of the element belonging to the first row and first column. This first one represents row and the second one represents column. That means A11, capital A11 means you have to find out the cofactor of the element belonging to the first row and the second column. Okay, sorry, first row and the first column. You have to get the cofactor of the element belonging to the first row and first column. First row and first column, that means 2. You have to get the cofactor of 2. First of all, you have to consider the sign. How can you consider the sign here? -1 whole to the power 1 plus 1 into. Now delete the row and the column through the element 2. That is, first row and first column are deleted. What remains? 1, 1, 2, minus 1. So it is 1, 1, 2, minus 1. Which is equal to, now we can simplify it, you can expand it. This is the second order determinant, right? What is minus 1 whole square? It is plus 1. So 1 into minus 1 is minus 1, right? Then it is minus 2, which is equal to minus 3. So I think I have understood it. Next, A12. A12 means, what is A1? Capital A1 is cofactor of the element belonging to the first row and second column. First row and second column. That means 8. You have to get the cofactor of 8. Let us first consider the sign. -1 whole to the power 1 plus 2. Right? Then next. Then you have to delete the row and the column through the element 8. That means first row and second column are deleted. What remains? 1, 1, 1 minus 1. 1, 1, 1 minus 1. Which is equal to. So what is minus 1 whole cube? That is minus. So within bracket expand the determinant. This is 1 into minus 1. Minus 1. Then comes minus sign always. So 1 ones are 1. So which is equal to how much is it? This is your 2. Right? Next one is A13. A13 means you have to find out the cofactor of the element belonging to the first row and third column. First row and third column means that is number 5. Consider the sign first. -1 whole to the power 1 plus 3. Then delete the row and the column through the element 5. First row and third column are deleted. It remains 1, 1, 1, 2. 1, 1, 1, 2. Which is equal to what is -1 whole to the power 4? It is always plus 1. Now expand the determinant. So plus 1 usually we don't write it. So cross multiply 2 minus 1, which is equal to 1. Right? Next, let us find out the cofactor of this one. That is A21. This means A21, that is cofactor of the element belonging to the second row and first column. Second row and first column. That is cofactor of this one. Let us consider the sign first. -1 whole to the power 2 plus 1. Now delete the row and the column through the element 1. Second row and first column are deleted. 8, 5, 2, 1. 2 minus 1. 8, 5, 2 minus 1. Which is equal to. Now it is -1 whole cube is always minus sign. So within bracket -8 minus. This is 5 2s are 10. Right? So which is equal to, this is, after simplification you will get plus 18. Clear? Next one is A22. Consider the sign first. -1 whole to the power 2 plus 2. What is meant by capital A22? Cofactor of the element belonging to the second row and second column. Second row and second. That means 1. You have to get the cofactor of 1. We have considered the sign. -1 whole to the power 2 plus 2. Now, delete the row and the column through the element 1. That is second row and second column are deleted. What remains? 2, 5, 1 minus 1. 2, 5, 1 minus 1. Is that understood? So now, what is -1 whole to the power 4? It is always plus 1. So which is equal to -2 minus 5, which is equal to -7. -2 minus 5, which is equal to -7. Is that understood now? So this is your capital A22. Next one is, so let us write down here, what is data? Data is equal to 15 because we need it. So let us write it here. Data is equal to 15, okay. Next, A23. So what is A23 now? Cofactor of the element belonging to the second row and third column. Second row and third column. Right? Second row and third column. That means this one. You have to find out the cofactor of this one, right? You have to find out the cofactor of this one. So first of all, consider the sign minus 1 all to the power 2 plus 3. Now we have to delete the row and the column through this 1. That means second row and third column are deleted. What remains? 2, 8, 1, 2. It is 2, 8, 1, 2. Which is equal to? What is minus 1 all to the power 5? It is minus 1. So write minus within bracket. Expand this second order determinant. You know how to expand it. 2 to 4 minus 8. Which is equal to how much is it? It is 4 only. 4 minus 8 is minus 4. So minus with minus plus 4. So next A31. What is capital A31? What is meant by it? You have to find out the cofactor of the element belonging to the third row and first column. Third row and first column. That means this one. So consider the sign first. Minus 1 all to the power 3 plus 1. Now delete the row and the column through the element 1. Third row and first column are deleted. Right? So 8, 5, 1, 1. 8, 5, 1, 1. Which is equal to, what is minus 1 all to the power 4 plus 1? You know that. So now you have to expand this second order determinant. 8 ones are 8 minus 5, which is equal to 3. Right? And next comes A32. So it is minus 1 all to the power 3 plus 2. Now we have to find out the cofactor of the element belonging to the third row and second column. It's third row and second row. That means 2. You have to find out the cofactor of 2. We have already considered the sign. Now delete the row and the column through the element 2. That means third row and second column are deleted. What remains? 2, 5, 1, 2. It is 2, 5. Sorry, 2, 5, 1, 1. 2, 5, 1, 1. Right? 2, 5, 1, 1. So is equal to, what is minus 1 all to the power 5? Minus. So within bracket expand this determinant. 2 minus 5. 2 ones are 2. Then minus 5 ones are 5. So it is plus 3. Is that clear? So next is your capital A33. Consider the sign minus 1 all to the power 3 plus 3. So again, what is meant by capital A33? Cofactor of the element belonging to the third row and third column. Third row and third column. That means minus 1. You have to get the cofactor of minus 1. Right? So we have already considered the sign minus 1 all to the power 3 plus 3. Now delete the row and the column through the element minus 1. That means forget about the row and the column through the element minus 1. That means this third row and third column are deleted. What remains? 2, 8, 1, 1. So it is 2, 8, 1, 1, which is equal to, what is minus 1 all to the power 6? It is plus 1. You know that, right? So it is 2 minus 8 is equal to minus 6. So 2 ones are 2. Minus comes in between the two numbers here. So 8 ones are 8. So 2 minus 8 is minus 6. Right? Is that clear to all of you? So we have got the cofactors of each element of the matrix A, right? So let us write it here, A11, because we need this one, right? Because I'll rub it. So what is A11? What was A11? It is minus 3, right? What is A12? 2. A12 is 2. What is A13? 1. A13 is 1. What is A21? A21 is 18, right? And A22 is equal to minus 7. I am writing here because I will drop this part. Okay, you don't have to copy this one because you may pause the video and see the previous part. Okay, so now you have to write down the cofactors of each element of this matrix A, right? So now let capital B be the matrix. So write down, let capital B be the matrix. Write down, let capital B be the matrix whose elements are the cofactors, of the elements of the elements of matrix A. Of matrix A. Let capital B be the matrix whose elements are the cofactors of the elements of matrix A. अब हामी matrix B लेख्नु पर्छ. त्यो matrix B मा चाहिँ each and every element will be the cofactor of each element of the matrix A, right? So capital B. What is capital B now? It is capital A11, capital A12, capital A13, capital A21, capital A22, capital A23. Next comes capital A31, capital A32, capital A33. Is that clear to all of you? So what is capital B now? Now write down. What was the value for capital A11? It is -3. -3. What is A12? It is 2. What is A13? It is 1. What is A21? 18. A21 is 18. What is A22? -7. And what is A23? What was A23? A23 is 4, isn't it? This one. A23 is equal to 4. Next, what is A31? It is 3. What is A32? It is also 3. What is A33? It is -6. So this is your -6. So I think you have understood it. Now we have to get the adjoint of A. So what is the definition of adjoint or adjugate of A? It is the transpose of B. So therefore, A is equal to B transpose. A is equal to what? It is B transpose. A is equal to B transpose. Therefore, A is equal to what is B transpose in this case? You have to change rows into columns and columns into rows in matrix B, right? So first column becomes the first row here, -3, 18, 3. Next, second column becomes the second row here, 2, -7, 3. And third column becomes the third row out here. That is 1, 4, -6. 1, 4, -6. This is adjoint of A. Now you can easily get A inverse. So what is the formula for A inverse? It is 1 upon det A into A is A, right? So or A inverse is equal to, what is 1 upon det A? It is 1 upon 15, right? So it is 1 upon 15. And what is A is A? You can copy it. What is A is A? -3, 18, 3. Next 2, -7, 3. And 1, 4, -6. So this is A inverse. So this is the answer for the first part. So I think you have understood it. Now we have to solve the given system of equations, right? So we have to solve the equations. So what are the given equations there? What were the given equations? Given equations. The given equations were this was question number 14. The given equations were 2x plus y plus z. It is equal to 2x plus y plus z is equal to -5. The next one, 8x plus y. 8x plus y plus 2z is equal to -24. 8x plus y plus 2z is equal to -24. And then 5x plus y. 5x plus y minus z plus 12 is equal to 0. Plus 12 is equal to 0, right? So now, what was the matrix A? You have to write down the matrix A also. What was matrix A? The matrix A was, what was matrix A? It was given as 285. It is 285, right? Then next it was 111. It was 111, and then 1 2 minus 1. 1 2 minus 1. Okay. Now you have to check this matrix A with this given system of equations. are the coefficient of x, y, z and this matrix A equal here? Here first row is 285, but here the first row will be 211. But here 211 is in the first column. Here in the second row it will be 812, but 812 is in the second column. Next, this 5, 1, minus 1. This is the row, third row, but here it is given in the third column. 5, 1, minus 1. Right? That means this is transposed, isn't it? This is transposed. So here in this case you have to write A transpose is equal to, now we can write A transpose. You have to change rows into columns and columns into rows, but because in the given system of equations these rows are changed into columns and columns into rows. That's why we are writing transpose of A. Let us write transpose of A. Then you can get this system of equations. That is 211 becomes the first row, then 812 becomes the second row, and 5, 1, minus 1 becomes the third row. That means this resembles with this given system of equations. That is 211 first row, yes, right. 812 second row is also right. 5, 1, minus 1 is also right. Okay. But I told you that from the given system of equations, you have to take all the constant term to the right hand side always in order to solve this equation, isn't it? That is plus 12 is taken to the right hand side, which is equal to minus 12. So this is your A transpose. Okay. Now let, what is capital X? What is capital X here? It is X, Y, Z, right? Is that clear to all of you? Next, which is the constant matrix here? Which is the constant matrix here? It is minus 5, minus 24, minus 12. This is the column matrix. This capital X is also the column matrix, and this C is also the column matrix. That is your constant one. That is minus 5, minus 24, and then comes minus 12. Then comes, it is minus 12. So I think you have understood it. Okay. So now this given system of equations, now we can convert them into matrix equation form. That is, what is matrix equation form? It will be A transpose X is equal to C. A transpose X is equal to C. Okay. So now in order to get the matrix capital X, you have to take that A transpose to the right hand side. So it will become A transpose inverse, or this will be X is equal to A transpose inverse. So when this A transpose is taken to the right hand side, it becomes what? It becomes A transpose inverse dot C. Is that clear to all of you? So next, there is a property for inverse of a matrix. If you have A transpose inverse is equal to A inverse then transpose. This is very important property. That is, A transpose inverse is equal to A inverse transpose, right? So here you can write, therefore X is equal to, capital X is equal to, A transpose inverse can be written as A inverse transpose dot C. Is that clear now? Next, or capital X is equal to, how can you get A inverse transpose? That means you have to transpose this A inverse. That means you have to change rows into columns and columns into rows in the matrix A inverse. So 1 upon 15 remains same here. So here this first row becomes the first column becomes the first row here, minus 3, 2, 1. Next, the second column becomes the second row here, 18, minus 7, 4. And this third column becomes the third row out here, 3, 3, minus 6. Is that clear to all of you? This first column becomes the first row here, minus 3, 2, 1. This second column becomes the second row here, 18, minus 7, 4. And this third column becomes the third row out here, that is 3, 3, minus 6. And now what is C here? So let us write C here. What is C here? It is minus 5, minus 24, then minus 12. Is that clear now? So I think I've understood it. So you can copy it. Now we'll multiply these two matrices, right? We will multiply these two matrices now. So now can you multiply these two matrices? For the first matrix, you have to check the number of columns. 3 columns are there. For the second matrix, you have to check the number of rows. How many rows are there? Here, 3 rows. That is, number of columns of the first matrix is equal to number of columns of the first matrix is equal to number of rows of the second matrix. That means they are equal. You can multiply the two matrices. Or capital X is equal to 1 upon 15. Now multiply these two matrices now. First row by first column. Minus 3 into minus 5 plus 15. 2 into minus 24 minus 48. And this is your minus 12. Is that clear? You know how to multiply the two matrices. Now second row by first column. 18 into minus 5 minus 90. Minus into minus plus 7 into 24. 7 4s are 28. Isn't it? 2. 7 2s are 14 plus 2 is 16. 168. Then minus 48. Then it is minus 48. That is 4 into minus 12 is minus 48. Is that clear? Next 3 into minus 5 minus 15. 3 into minus 24 minus 72. 3 4s are 22. 1 3 2s are 6 plus 1 is 7. Right? Then minus into minus plus. This is your 72. 6 into 12 is 72. Right? Or capital X is equal to 1 upon 15. Now we can simplify it further. 15 minus same sign, you can add them, minus 60. Then this is minus 90 minus 48. Minus 138 plus 168. Right? Then comes, this 72 gets cancels. You will get only minus 15. Is that clear? So next one is, or capital X is equal to 1 upon 15. 1 upon 15. Now you can subtract it. 15 minus 60. Different sign. You have to subtract it. So it is minus 45. Isn't it? 10 minus 5 is 5. This 5 minus 1 is 4. You have to write down the sign of the greater number. That is minus 45. Minus 138 plus 168. 8 minus 8. 0. 6 minus 3. 3. 1 minus 1 is 0. You have to write down the sign of the greater number, that is plus sign. So plus sign usually we don't write. So it is minus 15. Is that clear? Or what was capital X actually? It was small xyz. That was the unknown column matrix. Which is equal to now, this 1 upon 15 is the scalar multiplication of that matrix. So we can multiply all the elements of the matrix by 1 by 15. So what do we get? 1 by 15 into minus 45, minus 3, 1 by 15 into 30, 2, 1 by 15 into minus 15, that is minus 1. So we got the answer. So these are the equality of two matrices. From the definition of the equality of two matrices, you can equate the corresponding elements. That means what do we get? X is equal to minus 3, y is equal to 2, and z is equal to what? This is minus 1. So these are the answers. So x is equal to minus 3, y is equal to 2, and z is equal to minus 1. So this question is very, very important. Okay? So you can copy it, you can practice it at home, right? So now we'll do the next question, that is question number 17, right? So the question number 17 is, find the product of the matrices. The two matrices are given out there, okay? So you have to find out the product of these two matrices. First of all, you have to find out the product of that two matrices, and hence You have to solve the given system of equations, that is 2x plus 3y plus z is equal to 11, x plus y plus z is equal to 6, and 5x minus y plus 10z is equal to 34. So what do we see here is that, what are the coefficients of x, y, z here? This is 2, 3, 1. So this is given in the first matrix, that is first row is 2, 3, 1. These are the coefficients of here x, y, z from the first equation. And in the second equation, what are the coefficients of x, y and z? It is 1, 1, 1. This is in the second row, 1, 1, 1. And in the third equation, what are the coefficients of x, y and z? They are 5, minus 1 and 10. So it is given in the third row, 5, minus 1 and 10. Okay. So this matrix is the coefficient matrix, and this is the other matrix. Okay. This is any matrix is given out there. Okay. So let us assume the first matrix as A. Let A is equal to, what is A here? 2, 3, 1, 1, 1, 1, and it is 5, minus 1, 10. This is the coefficient matrix. And let us assume it as what? Let us assume it as D matrix, right? So what is D here? 11 minus 31, 2, minus 5, 15, minus 1, and minus 6, 17, and minus 1. That is D. Is that clear? So therefore, now we have to find out the product AD. So let us find out the product AD first. Because in the first part you are asked to get the product of the two matrices. Okay? So what is capital A here? It is 2, 3, 1, 1, 1, 1, 5, minus 1, 10. Then what is capital D out here? It is 11 minus 31, 2, minus 5, 15, minus 1, minus 6, 17, minus 1. Is that clear now? So next, what will you do now? So which is equal to, you can multiply these two matrices now, right? So let us multiply them. So which is equal to, let us multiply it. You have to multiply this matrix by this matrix. So row by column, first row by first column, corresponding elements should be multiplied. So 11 2s are 22, minus 15, minus 6, right? Then first row by second column, 2 into minus 31, it is minus 62 plus 45 plus 17. Is it clear? Next, is it correct? Let us check it. First row by second column, 2 into minus 31, minus 62, 2 1s are 2, 2 3s are 6, 3 15s are 45, 17 1s are 17. Then again, first row by third column, 2 6, 2 2s are 4, 3 into minus 1, minus 3, 1 into minus 1, minus 1. So this is the first row, right? Next, first row by, second row by first column. So 11 1s are 11, minus 5, minus 6, right? 11 1s are 11, 5, minus 5 into 1 is minus 5, minus 6 into 1 is minus 6. Then next, second row by second column, minus 31, plus 15, plus 15, plus 17, plus 17, right? Next one is second row by third column, 1 2s are 2, 1 into minus 1, minus 1, 1 into minus 1, minus 1. So this is your second row. Now you have to multiply third row by first column, 11 5s are 55, minus 1 into minus 5, plus 5, 10 into minus 6, minus 60, right? So next, 5 into minus 31, minus 155, 5 1s are 5, 5 3s are 15, but you should write minus sign here. Minus 1 into 15, minus 15, it is minus 15, and this is plus 170, right? Next one, this third row should be multiplied by third column, 5 2s are, it is 10, minus 1 into minus 1, plus 1, 10 into minus 1. What is 10 into minus 1? Minus 10. So matrix sign is closed now. So you know how to multiply the two given matrices, right? So let us simplify it. So which is equal to, what is the product now? This is minus 21, right? Minus 15 minus 6 is minus 21. 22 minus, this is 22 minus 21 is 1. Next, minus 16. This is 62 minus 62, 0. That is also 0, right? This is 11 minus 5 minus 6 is minus 11. 11 minus 11, 0. This is 17 plus 15. 32 minus 31 is 1. 2 minus 2 is 0. So next one is, what is the next one? 55 plus 5 is 60 minus 60 is 0. This is 170. Minus 15 minus 155 is 1 minus 170, right? Plus 170 is 0. And then this is 10 gets cancelled, you get only 1. Got it? So which is equal to I? Which is equal to I? Because this is the identity matrix. Because the leading diagonals, in the leading diagonal, all the elements are 1 here, but all other elements are 0 here. So this is the identity matrix. So I think I've understood it. Okay. So we have got the product of the two matrices, which is equal to I. So therefore, what is AD is equal to, this is I, right? Now let us take A to the right hand side, because you have to get A inverse out here. In order to solve these two equations, you should get A inverse here. That's why this A is taken to the right hand side. So it becomes, so D is equal to A inverse dot I. Right? Now you can put the matrix for D. You can put the matrix D out here. What is matrix D actually? What is matrix D? It is 11 minus 31, because we have assumed that second matrix as D, isn't it? So write down the matrix D. Which is the matrix D here? 11 minus 31, then 2. Next one is minus 5, 15, minus 1. Next, minus 6, 17, and minus 1. Which is it? This is the matrix. Then it is A inverse. So we have got A inverse. So what is A inverse is equal to, this is the matrix D. That is 11 minus 31, 2, minus 5, 15, minus 1, and minus 6, 17, minus 1. Is that clear? So we have got A inverse. Okay. Now we have to solve this system of equations. So let us assume, let capital A is equal to 2, 3, 1. That is the first row. You have to write down the coefficients of x, y, and z from the first equation in the first row. And you have to write down the coefficients of x, y, z from the second equation in the second row. That is 1, 1, 1. Next, you have to write down the coefficients of x, y, and z from the third equations. From the third equation in the third row. That is 5 minus 1, 10. 5 minus 1, 10. Is that clear? So next, let capital X is equal to unknown matrix x, y, z, and let capital C. What is capital C? It is the column matrix, but you should write here constants. So which are the constants out here? The constants should be on the right hand side. So all the constants are written on the right hand side in the given equation. That is 11, 6, 34. 11, 6, 34. It is 11, 6, 34, right? Now, you can convert this given system of linear equations into matrix equation. So how to write it? Ax is equal to C. Or what is capital X is equal to? A inverse C. When you take the matrix A to the right side, it becomes A inverse. Or capital X is equal to, write down A inverse. What is A inverse actually? A inverse is this one, that is matrix D, isn't it? What is that matrix D out here? It is 11 minus 31 2. Next is minus 5, 15 minus 1. Minus 5, 15 minus 1. What is the next one? Minus 6, 17. Minus 6, 17 and minus 1. Minus 1. Is that clear? That is your x is equal to, this is your matrix A inverse. Now write down the matrix C. That is the column matrix. That is the constant. What is that constant? This is 11, this is 6 and this is your 34. Understood? Now you can multiply them. Now you can multiply them, or capital X is equal to, now you can multiply these two matrices. For the first matrix, you have to take the number of columns. Number of columns is equal to 3. And for the second matrix, you have to check the number of rows. So here the number of rows is equal to 3. That is, here number of columns is equal to number of rows. That means you can multiply these two matrices. Okay. So capital X is equal to first row by first column. 11, 11 is 121. Minus 31 into 6. Minus 6 ones are 6. 6 threes are 18. 6 ones are 6. 6 threes are 18. Then 2 into 34. That is plus. This is your 68. Is that understood now? Now second row by first column. 11 into minus 5. Minus 55. 15 6 are plus 90. 15 6 are 90, isn't it? 6 5 are 30, 0, 3 6 1 are 6, plus 3 is 9. Then comes minus 34. It is minus 34, right? Then third row by first column. 11 into minus 6, minus 66. 7 in 6 are plus 6 7s are 42, 2, 4, 6 1s are 6 plus 4 is 10. Then minus 1 into 34 is minus 34. Now we can solve it. Our capital X is equal to 121 plus 68. Same sign, you can add them. 8 plus 1, 9. 6 plus 2, 8. 1. Minus 186. So here also you write 90 first. Minus same sign, you can add them. Minus 5 plus 4, 9. 5 plus 3, 8. Right? Then comes 102. Then write down minus sign. Minus same sign, you can add them. 6 plus 4 is 10. 1. 7 plus 3 is 10. Right? But actually what was capital X? What was capital X? That is the matrix, column matrix XYZ. Write down XYZ. So which is equal to, what is 189 minus 186? That is 3. 90 minus 89, 1. 102 minus 100, that is 2. So now these are the equality of two matrices. And from the definition of the equality of two matrices, you can equate the corresponding elements to get the values of x, y and z. That is, x is equal to 3, y is equal to 1 and z is equal to 2. So this is the answer. So I think you have understood it. So you can copy it. We'll do the next question now. So now we'll do the next question, that is from the same exercise, exercise 3, page number, it is 212, but each question carries 2 marks. So the question is, question number 5, using elementary row transformations, find the inverse of each of the following matrices. So in this case, you have to use elementary row transformations. So what is meant by elementary row transformation? So using elementary row transformation, you have to find out the inverse of the given matrix. So while doing the problem, I'll explain you about elementary row transformation. Okay. So here the matrix given is 3, 4, 2, 3. You have to find out the inverse of this matrix using elementary row transformation. That is, in this case, you have to use the property row wise. You know properties of determinant, isn't it? You know properties of determinant, that is properties of determinant. There were 5 properties and that 5th property was very, very important. That is, what was the fifth property? If each element of a row or a column be increased or decreased by a constant multiple of another row or column, then the value of the determinant remains unchanged. That was your fifth property. Okay. So now in this case you have to use elementary row transformation. That means you have to use the property for the row. You have to use properties for the row. Elementary row transformation. Sometimes you may be asked using elementary column transformation. In that case you have to use property in terms of columns, right? So I'll show you the method now. So what is meant by elementary row transformation? Let us do this problem. So now let us assume this given matrix as A. That is, let capital A is equal to 3, 4, 2, 3. But in this case you can write A is equal to IA, isn't it? Because you know that I dot A is equal to A. That means, so A can be written in terms of identity matrix and A, because you know that from the properties of the matrices, you know that identity matrix dot given matrix is equal to given matrix. Okay? Or what is capital A here? It is 3, 4. It is 3, 4. It is 2, 3. Right? Next, which is equal to, what is I here? It is 1, 0, 0, 1. Then what do we write here? We write here A. Is it clear now? Now in this case, using elementary row transformation. So what is meant by elementary row transformation? You have to change now this matrix A, that is 3, 4, 2, 3 into identity matrix. If you change this 3, 4, 2, 3 into identity matrix, this matrix will also be changed. Suppose if you change this 3, 4, 2, 3 into identity matrix, it becomes 1, 0, 0, 1, right? And suppose using elementary row transformation or using properties in terms of rows, if you change this 1, 0, 0, 1 into B matrix, then this will be A, isn't it? A remains same here. Is that clear? So now this is your identity matrix. So I is equal to B dot A. Then you can take this A to the left hand side. So what does it become? A inverse dot I is equal to B. So what is A inverse dot I? That is your A inverse, which is equal to B. Is that clear? So that means we can get the inverse of the matrix A, which is equal to B. B matrix will be there. Okay? So now you have to change this 3 into 1, 2 into 0, this 3 into 1 and this 4 into 0 in order to get this identity matrix. Okay? So now in this case, this 3 should be converted into 1, isn't it? This 3 should be converted into 1. Then this direction, you have to make this 2, 0. Then go in this direction, you have to make this 3 what? You have to make this 3 1. Then go in this direction, you should make this 4 what? You should make this 4 0. So this is the method. So first of all, you have to make this 3 1. Is that clear? After that, after you make this 3 1, you have to make this 2 0 by using properties in terms of row, right? Then after that, you should make this 3 1. After that, you should make this 3 1 using properties of determinant in terms of row. Then after that, go in the opposite direction, that is this term should be made 0, so that we can convert into 1 0 0 1. So it is the elementary row transformation. Okay, so let us use the method now. So this is only the method I have written out here. Now I will do the problem now. That is, you can write A is equal to I dot A, because I dot A is equal to A, right? So what is A out here? The U A को matrix है तिमीले लेख्नु. What is that? 3 4 2 3, which is equal to, what is I actually here? 1 0 0 1 A, right? Now in this case, how can you make this 3 1? That is row 1 minus row 2. This is row 1, this is row 2, this is column 1, this is column 2, this is also row 1, this is also row 2, this is column 1, this is column 2. And you have to keep capital A matrix as it is. Is that clear now? So now you can change, you can convert these 3 into 1. How can you change it? R1 minus R2, that is 3 minus 2, it will be 1, isn't it? So in this case, we can use this property. R1 is changing out here. So R1 is equal to what? R1 minus R2. That means this is elementary row transformation. That is, we are changing rows with the help of properties of determinant. Okay? So or, now it becomes, now row 1 is changing here. Row 1 is 3, 4 is changing. 3 minus 2 is 1. 3 minus 2 is 1, right? R1 minus R2. R1 minus R2. 3 minus 2 is 1. 4 minus 3 is also 1. Second row remains same. 2, 3 is equal to. On the right hand side also you have to change row 1. Okay? How does it change? R1 minus R2, right? So 1 minus 0 is 1. 0 minus 1 is minus 1. Then second row remains same. That is 0, 1. 0, 1 and this is E. Is that clear to all of you? So now what will you do now? Now you have to make these two 0. Below 1 there is 2. You have to make these two 0 in order to convert it into identity matrix. I already told you the method, isn't it? You have to make these two 0. How can you make these two 0? By writing, because you have to multiply. In this case you have to multiply the first row by 2 and subtract it from row 2. 2 minus 2 is 0. Right? That is problem number 5. I just told you. So R2 will be equal to R2 minus 2R1. If you multiply row 1 by 2 and if it is subtracted from row 2, 2 minus 2 will be 0. Understood? So or now here now row 2 is changing, not row 1. Row 1 remains same. 1, 1. What is R2 is equal to? R2 minus 2R1. That is 2 minus 2 into 1. 2 minus 2 into 1. 2 minus 2 will be 0. Is that clear? Next, this R2 is 3. Minus 2 into 1. What is 3 minus 2? Is always 1. I think it is understood. So which is equal to, on the right hand side also there is a matrix there. So row 1 remains same here also, 1 minus 1, right? Now this row 2 is changing again. R2 means 0, minus 2 into R1 means 1. So 0 minus 2 into 1. What is 0 minus 2? That is your minus 2. Next, there is 1. So 1 minus 2 into minus 1. This is 1. This is your 1 minus 2 into minus 1, which is equal to 1 plus 2, which is equal to 3. Is that clear? 1 minus 2 into minus 1. That means 1 plus 2 is equal to, this one is 3. And here it is capital E. So I think you have understood it. Okay? As a next, this is already 1. 1, 0, it should be 1, but it is already 1 here. Now we have to make this 1, 0, which is above this 1. U1 लाई हामीले के बनाउनु पर्छ? 0 बनाउनु पर्छ. अब U1 लाई 0 बनाउने मेथड चाहिँ के हो त? भन्दाखेरि R1 dash is equal to R1 minus R2. If you do 1 minus 1, it will be 0. So here you should write R1 is equal to R1 minus R2. So we are using transformation in row only. That's why it is known as elementary row transformation, right? So now let us write it again. Or now row 1 is changing. How does it change? R1 minus R2, 1 minus 0, 1. 1 minus 1, that is 0. Now row 2 remains same here, 0, 1. Which is equal to, now what is R1 minus R2 again? Here also you have to use the property R1 minus R2. 1 minus minus 2. This is 1 minus minus 2. Minus 2 minus plus 2. 1 plus 2 is 3 here. Similarly, minus 1 comes here. This is minus 1. Row 1 minus row 2 means minus 1 minus 3. Minus 1 minus 3. What is it? Minus 1 minus 3. Minus 4. Right? Then comes what? Row 2 remains same. That is minus 2, 3. And this is your A. Is that understood now? So actually we have converted this left hand side matrix into identity matrix. That means you can write here I, which is equal to, this matrix remains same, 3 minus 4 minus 2, 3, and this is your A. Now A is taken to the left hand side. What does it become? You know that A inverse dot I is equal to, this is 3 minus 4 minus 2, 3, right? So what is A inverse dot I? That is your A inverse, right? So this is your A inverse. So what do we get here? 3 minus 4 minus 2, 3. So that means we got A inverse. So this method is known as elementary row transformation. So using elementary row transformation, we have determined the matrix of the, we have determined the inverse of the given matrix A. So this is your answer. So I think you have understood it. I'll show you similar example now. So you can copy it. So now I am doing the next problem, but I am doing the similar type of problem out here so that you can easily understand it. Okay. So question number 5 is, again this is question number 5. Using elementary row transformation, you have to find out the inverse of the given matrix. So this is the given matrix out here. Minus 2, minus 4, 3, 5. So let us assume it as, let capital A is equal to minus 2, minus 4, 3, 5. So what is the method here? I told you already that the method is, you have to make this minus 2 1 by using elementary row transformation. You have to make this minus 2 as 1. Okay. Then you have to come down here. Then you have to make this term 0. Then again you have to go right hand side. You have to make this term 1. Then again you have to go up. You should make it 0. So that we can get here 1, 0, 0, 1. That is your identity matrix. Is that clear? So let us write here A is equal to IA. Or what is A? What is A here? Minus 2, minus 4, 3, 5. And what is I here? It is 1, 0, 0, 1. And this is your A. Now you have to convert this A matrix in terms of identity matrix. 1, 0, 0, 1. That means you have to make this first 1, then go this direction, downward direction, you should make it 0. Then right direction, you should make it 1, and then up direction, you should make it 0. Okay? So how can you make this minus 2 as 1? You have to use elementary row transformation. So if you multiply this first row by minus half, what is minus half into minus 2? What is minus half into minus 2? That is 1, right? So here you can change this row 1 as minus half row 1. Is that clear? If you multiply all the elements of the row 1 by minus half, so what is minus half into minus 2? That is your 1. Is that clear? So you are getting 1 out here. So let us use this transformation. That is R1 is equal to minus half R1. So what do we get now? This first row now becomes minus 2 into minus half. That is your 1. Minus 4 into minus 2. Minus 4 into minus half. What is that? Minus into minus plus. Half into 4 is 2. This will be your 2. Second row remains same. That is 3, 5. Right? Which is equal to. Now on the right hand side also, you have to change the first row on the right hand side also. That is 1 is multiplied by minus half. That is minus half. This 0 multiplied by minus half, what is it? What is 0 into minus half? That is 0. That is your 0. Then comes 0, 1. 0, 1, and you have to write capital E. So next, what is the method? You have to make this 3 0. You can easily make it 0 by using property number 5. You know property number 5. I told you in the previous problem what is property number 5, isn't it? Now you should make this 3 0. That means row 2 will be changed. How does it change? R2 minus 3R1. That means this one should be multiplied by 3 and it should be subtracted from row 2. That is 3 minus 3 will be, this one will be 0. Understood? So now let us use this property now. Or row 1 remains same, 1, 2. R2 is equal to R2 minus 3R1. That is 3 minus 3 into 1. 3 minus 3 will be always 0. Understood? Next, 5. 5 is here. Minus 3 into 2, 6. 5 minus 6 is, this is your minus 1. Is that clear? This is your 5 minus 3 into 2. That is 6. 5 minus 3 into 6. 5 minus 6 is minus 1. Right? So which is equal to now? Here also row 1 remains same. Minus half 0. Now row 2 is changing. How does it change row 2? R2 minus 3R1. Here R2 is 0. Here R2 is what? 0. You can write it in the rough part. R2 is 0. This is minus 3. Minus 3 into what? Minus 3. Row 1 is minus half. Minus half. So what is it? It is 3 by 2. So you can write here. It is 3 by 2. Understood now? Next. What is R2 here? 1. It is 1. Minus 3 into this is 0. Minus 3 into 0, which is equal to 1. Is that clear? So this remains as it is, that is 1. That is your A. So I think you have understood it, right? Next, what will you do now? Now in the next step, now you have to make this minus 1 as plus 1. How can you make it? How can you make this minus 1 as plus 1? You may multiply all the elements of the second row by minus 1 to make it plus 1, isn't it? I think I've understood it. What I mean to say? If you want to make this minus 1 as plus 1, you have to multiply all the elements of the second row by minus 1 also. Or you may do this. You may do R2 plus R1. Sorry, yes, R2 plus R1. What is R2 plus R1? What is R2 plus R1? Minus 1 plus 2 is 1. 1 is out here. So you can use this property, that is R2 is R2 plus R1. I already told you that in determinant, I told you that whenever you write R2 here, you should write R2 first, not R1. R2, it may be minus, it may be plus R1, right? So next, or. Now only row 2 is changing here, not row 1. So row 1 remains same, 1, 2. So how does this row 2 change? 0 plus, oh, you cannot do it. Because 0 plus 1 will be 1 here, no? So you cannot do R2 is equal to R2 plus R1. You cannot write it here. Is that clear now? That means, so I think I understood it. This 0 plus 1 will be 1 because it is already made 0 out here. So you cannot make this 1 or something like that other than 0. Okay? So in this case, what we will do here is that this minus 1 is here. So you should make it 1. So let us write R2 is equal to minus R2. R2 is equal to minus R2. That means all the elements of row 2 is multiplied by minus sign. Right? So, or, now this first row remains same, 1, 2. Now second row is changing. How does it change? You have to multiply by minus sign here. 0 into minus into 0. Minus 0 is always 0. So minus into minus plus 1. Right? Is that understood now? So which is equal to, on the right hand side also, you have to change row 2 only, not row 1. Minus half 0. What is minus R2? Minus 3 by 2 and minus 1, isn't it? And this is your minus 1. That means all the elements of the second row are multiplied by minus sign. And then you have to write E. So we cannot use here R2 plus R1 because this 0 is changing. If you change this 0, then it's wrong. Okay? You don't have to change this 0. You can't change this 0. Okay? So we are using this transformation, that is R2 arrow mark minus R2. That means all the elements of row 2 is multiplied by minus sign. Okay? Now we have changed the sign here, 0, 1, minus 3 by 2, minus 1. Right? A remains same. Now we have to make these two 0. If you make these two 0, then you can get A inverse. Is that clear to all of you? Now what is the method here? You have to make it 1, 0, 0, 1 by using elementary row transformation. So how can you make this 2, 0? R1 is equal to R1 minus 2R2. That means this one should be multiplied by, that is this element of the second row should be multiplied by 2 and it should be subtracted from row 1. Right? That means row 1 is changing out here. So how does it change now? So R1 is equal to R1 means 1. Minus 2 into 0, 0, 1 minus 0 is 1, right? What is R1 minus 2R1? 2. 2 minus 2 into 1. 2 minus 2 into 1. 2 minus 2 is 0. Second row remains same. This is 0, 1. Which is equal to, on the right hand side, here also row 1 is changing, right? So how does it change? So you can write it in the rough work. I think you have understood. Okay. So how does it change row 1? R1. R1 means minus half. R1 means minus half. Then minus 2 is there. Minus 2 into what is row 2? Minus 3 by 2. Minus 3 by 2 is there, right? Is that clear? R1 means minus half. Minus 2 into minus 3 by 2, right? So which is equal to minus half. This minus 2 minus plus 2 gets cancelled. This is your 3, right? So which is equal to, how much is it now? This is 3 2s are 6. What is 6 minus 1? It is 5. So it is 5 by 2. Understood? 3 2s are 6 minus 1, 5 by 2. So this will be your 5 by 2. This is your 5 by 2, right? So I think I understood it. Okay, look at the blackboard. What is R1 here? Minus half. Minus 2 into what is R2? Minus 3 by 2 is there. 2 gets cancelled, so it is minus 0 minus plus 3. If you simplify it, you get 5 by 2. So next, second element of the row 1 is changing. How does it change? R1 minus 2 R2. R1 means now it is 0. 0 minus 2 into what is R2? That is minus 1. So which is equal, how much is it? 2. So here you can write 2 here. Understood now? So this is your 2 only. So this is second row remains same. We are changing only row 1, not row 2. So row 2 remains same, minus 3 by 2, then it is minus 1. So it is E. Is that clear now? So next, what is 1 0 0 1? This is your identity matrix, which is equal to, now this matrix remains same now, that is 5 by 2, 2, minus 3 by 2, minus 1, and there is E, right? Since you have to get the matrix A inverse, you can take that A to the left hand side. So when this A goes to the left hand side, it becomes A inverse dot I is equal to, this is 5 by 2, 2, minus 3 by 2, minus 1, right? Now what is A inverse dot I? That is your A inverse. What is A inverse dot I? It is just like multiplying with 1. That is, it is only A inverse. So what is this answer? 5 by 2, 2, minus 3 by 2, then this is minus 1. So this is the final answer. So I think you have understood it. So you can copy it. So you revise all the problems that we did today. Okay. So this was for today. In the next class, we will do how to get the inverse of a matrix using elementary column transformation for both second order and third order. Okay. So this is only of second order. these are examples of finding out the matrix, finding out the inverse of a given matrix using elementary row transformation. So in the next class we'll do how to get inverse of a matrix, both second order and third order, using elementary row transformation and elementary column transformation. Okay.